Hey guys, welcome back to the shop. I want to give a quick little update on this engine lathe. I've done some more testing and found some more problems. So real quickly we're going to go over what I've uncovered. So you're looking at the top of the headstock, and these are the spindle speed gears. And this is a pretty standard sliding gear arrangement. So the clusters of gears slide back and forth, and that's how it changes its ratios. Anyway, I was able to find a spot where all of the input gears are isolated from the spindle. So if I turn the spindle, it's just spinning by itself, none of the other gears are turning. And then the only gear that was left was this output gear for the power feed. And I just there's a pointed set screw. This guy here, it's got a little point on it, and it's engaged into a spotted hole in this shaft. So if you take the set screw out, you can drive that shaft forward. And that's a pretty standard construction method for this type of gearbox. The only thing to watch out for is a lot of times they put two screws on top of each other. So you'll take the top one out, and then you'll miss the bottom one, and it'll still be held. So anyway, I highly suspect now that the spindle bearings are bad, and I can't get any deviation on the dial indicator testing at the front, and they really sound okay. But when I rotate the spindle by hand, like I am right now, what I can feel is kind of like some cogging. So it kind of basically cogs a little bit, and I suspect that's because the bearings are worn. I think they call that kind of wear brinelling. So basically what happens is the ball or the roller in the bearing tends to, it wears a spot, and then every time another ball passes that spot, it causes it to cog a little bit, and eventually it will completely destroy the bearing. So I think that's what's going on here. It's impossible for me to convey that through the camera, but just feeling it, I think that's what's going on. I did find another bearing that's bad too. This one here on this counter shaft. It's definitely bad. I don't know if you can hear it on the camera, but it sounds terrible. It's just a standard deep groove ball bearing though, so I can replace that one. Other than that, I didn't find anything majorly wrong in the gearbox. All the teeth are good. The shift levers seem to be working okay. They're a little sloppy, but it's shifted by this double cam right here, and that's not a terrible system. It's better than some I've seen, and it seems to work okay. I may try to tighten it up just a little bit. The other thing that's kind of crappy that I found is that normally when they design a sliding gear type of a gearbox, they'll round over the teeth, because these gear teeth have to slide into each other. It's not a constant mesh, and so they'll hob the gear, and then they'll put it onto another machine called a tooth rounding machine, and it rounds the end of the teeth. And they kind of did that on some of the gears, but they did a really bad job. And then, like in a lot of cases, if they have two gears that slide together, they rounded one but not the other, and it just makes it really hard for you to slide the gears together. And it's definitely just a quality issue on their part. They cheaped out, or they didn't catch that tooth rounding wasn't correct when they made the gears. So definitely something that's a little crusty on this machine. You would never see that on an American-made machine. So, alright, this is the page from the manual that shows the schematic of the spindle bearings, and this is the chuck side here, and then the tail end is here. So you can see the way it's set up. It's a roller bearing here. So this is a roller bearing, and then it's on the inside race is a taper, and so there's a spacer here and a double nut. You basically just tighten this nut, and it forces that inner bearing onto the taper, and just that taper is enough to expand the inner bearing slightly, and that takes up any any backlash in the bearing. So that's the preload mechanism for these bearings. And then I'm not exactly sure how they've done this thrust bearing in the front, because you can see here it's a double thrust bearing on either side of a thrust washer, or whatever you want to call it, large thrust race here. And then that thrust bearing pushes against the inner race of the front roller bearing, and that's what sets the preload. So it doesn't seem that it's possible to adjust the preload of the thrust bearing. It must just be whatever it is in order to get the preload on the roller bearing correct, and that's set by this nut here. It shows a double nut, but it's actually a single nut in the machine with a clamp on it, and so it just pushes these gears up against that thrust bearing, and that's all that sets the bearing preload. And then this is a labyrinth seal at the front, so it doesn't appear that it would be too hard to get this apart. I'm not exactly sure how the D16 spindle nose factors into it, but most likely the whole thing has to come out this way. So we'll have to see if we want to do that or not. So another reason that I think the spindle bearings probably are bad is I did some more testing after the last video, and we know that there's wear in this cross slide, of course. So I rigged up these bar clamps just to try to eliminate the cross slide from the equation, and these bar clamps basically lock the slide out. And I took another, several more test cuts, and I still was not able to get a nice surface finish. So other than issues with the chuck, which I think that there probably are some issues with the chuck, it still seems like the poor surface finish is coming from the spindle bearings. So a lot of signs are pointing that way. I did some playing around with the ways, and they are hard ways, but it seems like it is possible to scrape them. And it seems, since we only have 3/1000ths, maybe 4/1000ths of total wear, I think it might be possible to solve that or correct that by scraping instead of sending the bed out to be ground. Grinding would be faster, obviously, but it's kind of a pain in the butt for me because I have to send it probably to Chicago or Milwaukee in order to get that done, and obviously there's some expense involved. And the other problem is that the entire machine has to be stripped basically down to nothing, because in order to grind it, they're just going to want the bed. So if we can scrape it, I would prefer to do that. So I scraped the tailstock ways. I don't know if the tailstock ways are hard or not, but I would assume that they're all kind of equally hard. And then I did a little test here on the V way, and it is hard, but it is possible to scrape it. So I don't know. Normally I would say you're wasting your time scraping hard ways, but we don't have to scrape a lot, so maybe it's worthwhile. I found this Ukrainian guy on YouTube who rebuilds lathes, and they scrape hard ways all the time. So I know it's possible. It's just a question of motivation.